Yeah.
Okay. So yeah, my name is João. I'm a KDP associate and also a PhD student at Teesside University. I will be presenting my research about my KTP project entitled Reality Capture and Visualization of Oil and Gas Facility Data for Operations and Decommissioning. So just to give a brief idea of what a KTP project is, so knowledge transfer partnership. Essentially, I'm employed by the university. It's a research project, applied research, but I actually am based at the partner company, which is Unisys. So the expectation is that this project will provide some outputs for academia, but also very immediate outputs for the company, which is where I'm based. So currently the project is very much focused on decommissioning of oil and gas facilities, because this is actually an emerging market right now, especially for facilities in the North Sea. And currently our major project at the company is decommissioning of a floating production vessel. However, we have to consider that there are key challenges in decommissioning projects. The truth is, a lot of these facilities have been operating for 20 or 30 years, and they were not built with decommissioning in mind from the start. So it can be very challenging to retrieve the data that we need from these facilities. Actually, what we do at Unisys, we provide an asset management software for oil and gas companies. And so it can be very challenging to trace back all the data from these facilities, which sometimes they've changed owners. So it's quite complex. And also, we don't have 3D models or visual models of these facilities as well. To help with these challenges, the most recent effort in terms of standards is the CFOS project, which Unisys is also, it's basically a consortium of oil and gas companies, and Unisys is also part of this consortium. So the overall aim of the KTP is actually to develop a CFOS compliant software tools to manage data from the whole life cycle of oil and gas facilities. However, for this presentation, I'm focusing on visualization methods and mostly for decommissioning and operations. But this is the aim and objectives of the whole KTP project. So to provide the visualization, we've explored two approaches. The first one is visualization of 3D data, which was obtained using a laser scanning survey. And the second one is using 360 photography, which is used to develop walkthroughs for the platform. And both of these can be linked to our asset management system. So the overall workflow for both approaches consists in starting by the identification of critical areas and tags, then follows the actual survey, and after that, what I'm actually focusing on the paper, which is the development of the walkthrough and linking it to the asset management data. So for the first approach to visualize 3D data, after we have performed the laser scanning survey, we use Recap to generate point clouds and to optimize the point cloud as well. Given that oil and gas facilities have very complex geometry in terms of piping and all the assets, it's quite different from a building. It's very difficult to model these assets from the point cloud. So what we actually did was split the asset in terms of the text structure that we have on our database, and use the recap web service to generate meshes for these specific sections. And then we can combine the model in 3ds Max, and we use Unity to provide the walkthrough and interaction with linking and interaction with the Unisys system. So here we have, this is the facility that we performed the laser scanning. It's actually, so it's a normally unmanned installation. It's quite a small facility. However, we needed to do a large number of laser scans for this. And as you can see, we have a quite detailed point cloud. So the model itself is actually really heavy. It's about 3 gigabytes. Here we have just an overlay of some of the point cloud and some of the generated meshes from the point cloud. And then finally, we can import our mesh model into Unity, and we can link to the database. We can interact with the assets and bring up tag data. The second approach slightly different. This second approach, we actually applied it to our current decommissioning project, which is a large floating production vessel. Basically, we captured a lot of, for this one, we actually captured about 1,000 photographs of the topside, and we use a software called Panotour to bring the photographs together and develop a walkthrough. We can accomplish the integration with our asset management system through URL linking. So just a quick overview of what actually is the Unisys CMS. That's on the right side, just one of the main screens. And on the left, this is just a part of the database schema, and I've just highlighted area, location, and tag, which is how we link to the visuals to the database. So, for example, when we go onto our area screen, we can see which areas have associated walkthrough, and we can interact with it. Similarly for locations, which is basically an area encompasses several locations, so it's more detailed. And finally, at tag level as well, we can see which tags have associated visual data. So just to give a quick example here, when we log onto the system, this is what we see for this facility, just general description. We can go on to areas, for example. We can see which of the areas have walkthrough by the symbol there. We can select one of the areas, bring the information about that area, and we can go into the walkthrough and explore the platform. And also, we can find some assets with some tag data, and we can interact with it. We can bring the data about it. We have all the data here, including PNID diagram, and we can also close this and go back to the walkthrough and continue exploring. So after experimenting with these two methods, there are some conclusions we can yet. Basically, for the visualization of 3D asset data, we had some challenges related to the data size and the complexity of the geometry. So the first challenge here was modeling the assets, because of the complex geometry is quite difficult, and we don't have that many tools that help us do this, unlike in the architectural domain. And also, it's very difficult to find the compromise between the accuracy of the model and the performance of the environment, especially considering that this is a web application, so we need to provide the users with a good experience. So we can conclude that the first method is appropriate for small assets, but will need further development if we are to apply it for the whole rig. For the second method, we had some challenges related to the number of photographs and links that were defined in the software, especially for the floating production vessel. We're talking about 1,000 photographs for that project. But we were able to achieve the integration of this at area, location, and tag level. This method is also can also be used for condition assessment, since we have actual condition of the vessel. And like I said previously, the method has been successfully applied to floating production vessel and a small, normally unmanned installation. So actually we are using this second method on our current decommissioning project. So some of the future work for this research will be in terms of combining both methods for visualization of the assets, where we can use the photograph method for a general walkthrough, and then we can capture critical assets or components when we need to know actual dimensions for decommissioning and operational purposes. So this concludes my presentation. I welcome all your questions.